7-4, special right triangles. We're going to use the relationships among sides in special right triangles. Our special right triangles are actually a 45-45-90 triangle and a 30-60-90. So looking at the 45-45-90 triangle, if you take a square and cut it in half by drawing it on the diagonal, you will get two isosceles right triangles. And the angles will be, because that diagonal splits, will be 45 and 45. If I look at the smallest unit square, where the sides are 1, to find the length of the hypotenuse, I take 1 squared is 1 squared. And then I need to take the square root of that. So the hypotenuse would be the square root of 2. So that sets up our relationship between our legs and our hypotenuse. So in a 45-45-90 triangle, the hypotenuse will be the square root of 2 times as long as each leg. Or written, it would be hypotenuse equals leg times the square root of 2. What I like to do is I like to identify and label my parts of my triangle and then give you two scenarios. The first is if you're given the leg, the hypotenuse will equal the leg times the square root of 2. Or if you're given the hypotenuse, the leg will equal the hypotenuse divided by the square root of 2. We cannot leave the square root of 2 in a denominator, so you must rationalize. And you'll see that in our examples, how to do that. So in our first example, the first thing I would do is label our parts. So we're trying to find the hypotenuse, which is the leg, times the square root of 2. So x, which is the hypotenuse, equals 4 root 2. The second one, identify our parts. We're trying to find a hypotenuse again, because we're given the leg. So x equals 6 root 2. Example 3, we're given the hypotenuse, so the leg equals the hypotenuse divided by the square root of 2. So it would be 3 root 2 divided by the root 2. Those two are going to cancel out, and we just get 3. The next type of triangle is a 30-60-90. And in a 30-60-90, we have 3 parts. We have the side that is opposite the 30-degree angle, which is called the short side. We have the side that's opposite the 60-degree angle, I call the long side, and then the hypotenuse. So the hypotenuse is 2 times or twice as long as the shorter leg, and the longer leg is going to be the square root of 3 times as long as the shorter leg. So the hypotenuse is 2 times the short leg, and the longer leg is the short leg times the square root of 3. So our relationships are within or compared to the short leg. So let's come up with our scenarios for this. So given the short side, which is what this theorem just said, the leg equals the short side times the square root of 3. And the hypotenuse is 2 times the short side. If we're given the leg, we must find the short side first. The short side would be the leg divided by the square root of 3, and the height would be 2 times the short. And then the other scenario, or the last one, is if you're actually given the hypotenuse, have to find the short side first, which would be the hypotenuse divided by 2, and then the leg is still short side times the square root of 3. So we're going to do these problems in the same way that we did the 45, 45, 90, by labeling the parts, the short side, the long side, the hypotenuse. Look at what you're given. In number 7, you're given the short side. So you can find the leg, taking the short side times the square root of 3, which is 2 root 3. And the hypotenuse is 2 times the short side, which would be 2 times 2 equals 4. So again, label your parts, and you're given the hypotenuse this time. So I have to find the short side first, which equals the hypotenuse divided by 2, which is 6 divided by 2 is 3. And the longer side is the short side times the square root of 3. In this one, we have short side, long side, hypotenuse. So this time we're given the long side. Have to find the short side first. So it's the long side divided by the square root of 3. So you have the square root of 3 divided by the square root of 3, which is 1. And the height is 2 times the short side, which is 2 times 1 equals 2. We have our 2 special right triangles here and just a table of values. So just some more practice where we can just use one diagram. So label parts. So our x values are the leg, and our y values are the height. So I'm going to highlight those that are going to be done in the same way. The easy ones are when you're given the leg. So the ones highlighted in red are given the leg, and we've done the same way. And the ones highlighted in green will be done the same way. So let's do the leg first. The height would be the leg times the square root of 2. So this is just very easily going to be 5 root 2. See if I can find a darker color that'll show up. 5 root 2. So just be 9 root 2. And that one will be the square root of 2 times the square root of 2, which is 2. My green ones are going to be, to find the leg, is the height divided by the square root of 2.